Hi everyone, and welcome to this video on Laplace expansion. Laplace expansion is our method by which we can determine the determinant of any square matrix, whatever the dimension of that square matrix ends up being. In this, consider this example, right? So we have here matrix F, and it is clearly a square matrix with 3 rows and 3 columns. We have a 3 by 3 matrix. We'll go through the steps in Laplace expansion slowly for us to be able to get the concept fully. Step one, okay, we need to choose any row or column, right? Column. Ideally, one with the most zeros. Now, the reason why we would want one with most zeros is not generally apparent, but as we go through the procedure, it will become reasonable as to why we want a row or a column with the most zeros. In our example, okay, let's choose row one. Okay, let's choose row one. So in row one, okay, so notice this matrix here, right? In general form, it's A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, and what we're doing now is we are zeroing in on this first row. Okay, now what we have here is if we choose row one, there are 3 elements inside row 1. So 3 elements in row 1. Okay. In row 1. So you have A11, A12, and A13. So you have 3 elements in row 1. Okay. Now, I call this the next step would be to build what you call the minor matrices, or the matrix of minor. So step 2. Okay. Build minor matrices. Right. So what we're gonna do is if you have if you selected a row already or a column, what you're gonna do is you're gonna try and derive the minor matrices for each element that we have. So in our choosing of row one has 3 elements. We will have 3 minor matrices. So we're gonna have we denote a minor by M. So we have M11, okay, and then we have M12, and then M13. Okay, let me just put this a little bit lower. M13, right? So how do we get M11? Okay, so let me just rewrite matrix F here so that it's easier for us to do. Okay, so we have here 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. M11 is the remaining part of the matrix wherein you delete column 1 and row 1, right? 1, 1 is column 1, row 1. So let's take this out and let's take this out. So what we're left with is 5, 4, 2, 1, right? 5, 4, 2, 1. Then when we get to say for example next is M12, so we delete the first row, the second column, so we delete those 2, and what we're gonna be left with is 6, 4, 3, 1, right? And the last, you know, if we if we delete the first row, third column, okay, the third row, third column, this one, 6, 5, this should be a 2. Sorry about that. So we're gonna be left with 6, 5, 3, 2. Okay. Then what we need to do is we need to get the determinant of these minor matrices. So the determinant of the 2 by 2 is straightforward. It's AB minus BC. So this is 5 times 1 minus 4 times 2, which is equal to -3. Next, we have here 6 times 1 minus 4 times 3, which is -6. Last, we have here 6 times 2 minus 5 times 3, which is -3. Okay. So after we computed for the minors, okay, step 3 is gonna be get the cofactors. Get the cofactors. So we have here the cofactors. Then for us to do this, okay, it's simple. If we have 3 elements, 3 minors, we will have 3 cofactors. So C11, C12, and C13. This one will be equal to, this has a standard formula, Cij is equal to -1 I plus j times Mij, right? So we're gonna have -1 times, raised to rather, C11 is on the first row, first column, so it's 1 plus 1 times the minor, the M11, that's -3. Hence, we have here -3, right? Because this one will be +1 times -3, that's -3. Next, -1 times 1 plus 2, right? Because 1 row, 2 columns, 1 row, second column, first row, second column rather. Then times -6, therefore you will have here 6, right? And the last, -1, 1 plus 3, so that becomes positive times -3, positive times the negative is still -3. Then step 4, so we now computed the cofactors. Step 4 is just use the formula and get determinant. None. Okay, so what we're gonna have is that the determinant of this matrix F is going to be equal to, okay, so we have here the cofactor C, it's gonna be the general form is sum I is equal to 1 to n, whichever number you have, okay, and then it's going to be a I j times Cij, right? So it's gonna be that formula. So this is just simple. So we have the first our element in A11 is going to be 9, right? So that's A11, that's 9, right? 9 times the first cofactor is -3 plus the second one is 8, right? So 8 times the second cofactor is 6 plus the last one is going to be 7 times the last cofactor, which is 3. So you have your -27 plus 8 times 6 is 48, minus 21, and you get 0, right? So the determinant of this matrix is equal to 0. And that's how we use Laplace expansion. Thank you very much for your attention, and I'll see you in the next video. Thank you.